Hello. I would like to add that I had this GIF in my presentation when I wrote it several months ago, not knowing that I would be still quite drunk from last night. So, as some of you who already know me know, I used to work for these guys. And we got bought by these guys, which is a lot like working for these guys, except sometimes a bit more like this. I do sometimes sleep in a Borg alcove. So aside from work, I do other weird things, like things with lasers and things with old computers, some demo scenes, things like that. So, under Cisco we have this concept of service ownership, which is essentially somebody who is in charge of a particular service. So I cover off binary application assessments, but also hardware reviews, hardware assessments and cryptography reviews. Although I should point out that a big heavy Windows in front of the binary applications, because I don't know shit about Linux. Yeah, I'm a Windows monkey, so just keep that in mind. So service ownership involves a few different things. It means that you write the testing methodologies for particular types of assessment. Any kind of like checklists of things that people need to go through. For example, if you were doing a web app, you would be wanting to look for, I don't know, whether it signed you out after a particular amount of inactivity, whether it, there's SQL injection in the login, and whether you can just try and just put blank login and password and see if you go through. Just silly things that are in a checklist. That's the kind of things that I end up writing. Developing tools specific to doing particular types of work, and doing research, which I tend to be doing more of recently. So the scope of this talk is some sort of general tips and tricks around binary applications, the common vulnerability types that I tend to run into, why they suck, how to find them, how to exploit them, how to fix them. Because if you're going to be doing pen testing, that last part is really important for when you write a report for a client. Safety and cover your ass. If you're running a binary application that's given to you by a client, you don't know anything about it. It's an arbitrary binary. Generally, you do have to install it. So install it in a VM and be sensible with the VM configuration. But that also means that you need to protect the client data. So you can't just, stick some application on your host, then uninstall it and hope that all the files went away at the end of it, and then it turns out that you had a bunch of production data that it pulled from the database in a cache on your hard disk, and you've just been wandering around with it for 6 months. Client ain't going to be too happy if they find out about that. And log what you're doing. When you do things, why you do them, who you spoke to. It's quite useful to do that. Just because if there is ever a problem, that's just good advice for any kind of testing, to be honest, and limiting the scope as well. So try and cut things down to just not bloating everything out everywhere. So what are binary applications? Basically anything with one of those file extensions. Yes, binaryapplication.exe, it goes to the moon. It's not a mobile app. They're the same thing, but they're on different platforms, therefore they're different. We don't tend to, at least in Cisco, we don't tend to talk about mobile apps as binary applications. We do them separately because there's a different ecosystem and some of the security controls are different. You've got things like intents on Android and things like that, which I have no idea about. 99.9% of what we see is Windows binary applications. Occasionally, we will get something scoped as a binary application that later turns out to be an AS400 green screen application. And that's great when you turn up and you don't have the faintest clue about what it is. So yeah, be careful with that, because people tell you things are binary applications when they're perhaps not what you would consider to be a binary application. But yeah, 99.9% of what we see is Windows. We do some Linux stuff, some bit of Mac OS stuff. Most of that tends to be cross-platform stuff that sits on these cross-platform frameworks where you write one application and deploy it in 3 places. Sometimes it's drivers and things like that. Client applications, so they could be just standalone stuff. Think of something like Notepad. There's a binary application. Server applications, obviously the other side of this. Sometimes we are testing that kind of stuff. think sometimes binary applications are serving out like some sort of web service or something, and then handling the request in a specific way, rather than having, for example, an ASP.NET server. They actually write a custom binary application that has a bunch of stuff in there, and we would be testing that as a binary application as well. And sometimes it's browser hosted. So unfortunately, people still do things with Silverlight in 2018, as I found out recently. So if you follow me on Twitter, you will have seen me being very salty about the fact that I had to test a Silverlight application, because it's hateful, and it makes you install very specific requirements, and doesn't work on Windows 10 anymore, which is great considering this was a new application designed for customers. Apparently customers that only run IE 11 and not Edge. Yeah, so, but also Java applications in the browser as well. Unfortunately, yes, Java applets in the browser are also still a thing. And then occasionally you get all of the weird stuff like ActiveX, and just, they make me sad. And the scope does include communications. If you're testing a binary application and it's talking to something else, those communications that it does are in scope. Now, whether the remote server is in scope depends on the particular assessment and how that's the scope of that's been written out. If it's not explicitly in scope, it isn't in scope. You can test what happens with the communications coming into the application, but not going back out. Because a lot of the time, a company will be like, actually, this is shared across 3 different production environments. We'd rather you not poke at it. So if you want to learn how to test binary applications, unfortunately, the first 2 hurdles is learning how to read C# and Java. If you don't like reading C# and Java, maybe this isn't for you, because almost every application that I end up testing is C# or Java. Occasionally, it's a compiled language, terrible term. It's something that compiles to assembly for a particular machine. So yeah, unfortunately, C++ and C and VB6 and Delphi and Pascal are still around, and occasionally very, very strange other things that you're just like, what the hell is this? So yes, you do unfortunately also need to learn assembly to some level. Not always, because most things are C# and Java, so you can often get away with it. But yeah, unfortunately, assembly is also something that you generally have to pick up. But then again, there are so many good resources on that these days that it's actually not that hard. If you already know a bit of programming, then it's actually not as tricky as it looks. It just looks really horrible because you look at it and you're like, what the hell does any of this mean? It doesn't have any like formatting. It just looks awful. It's all procedural. But yeah, it's actually not that difficult once you start looking at it. And yeah, getting comfortable with the particular tool set that you've chosen. The great thing about binary application testing is that for almost any case that you run into where you're like, I would like to do this, you usually have like at least 2 or 3 different tools that you could pick. I think at some point I did actually have I think I moved a slide around, so unfortunately my choice of tools might be randomly somewhere else in here. So I'm guessing most of you are familiar with the terms black box and white box test. Black box test is, here is the thing, we're not going to tell you anything about it, go break it. And a white box test is, here is a thing, here is all of its source code, here is all of its documentation, here is everything about how it works, go dig around in it. More often than not, actually, these days, we're doing both. Which is actually quite good, because if you spend a lot of time, if you're given the code, you can spend a lot of time going through the code and digging through it and trying to find vulnerabilities that way. And you might not necessarily think to try something that's really dumb, that you would have not thought about, that you would have thought about if you were just sort of hammering away at a black box. If you look at something as a white box, you get an understanding for how it fits together, and you can often, it's just human nature to go, oh, well, that wouldn't work because clearly this piece of code here, and then you could have missed something. So doing a black box test and then a white box test is actually quite common these days. And it just gets around that like weird thing that everybody does, which is just getting stuck in a particular mindset about something. Areas of focus. Right, so you're going to test a binary application. How do you start? Well, you want to look at all of these things. Business logic is the big one. I'm going to go through, my tools of the trade slide is on the next one. I have moved it around somewhere for some reason. I don't know. Yes, the business logic is the main key. This is basically what does the application do and why does it do it. It's meant to be enforcing or doing some sort of, fulfilling some sort of role within an organization. So yeah, if it's not doing that, then actually that's often a security failure, because that particular role might be who can get a firearms license. If you can bypass the normal restrictions of that, that's a bad idea. So yeah, authentication and session management, of course, we'll know what that is. Logins, sessions, blah, blah, blah. Network communications. Who's it talking to? Why is it talking to them? What data is going over there? How is that data protected? What can you do if you mess with that data? Data at rest. Does the application store cached data? Does it do that in a safe way? And what's the impact of the system? If you install this application, does it make your operating system less secure? And now my out of place slide, which I accidentally moved around. These are the tools that I like. Wireshark for networking stuff, like just viewing network traces. Burp Suite and Zap, probably a lot of you know of because of web application testing. It turns out it's also really useful for binary applications, because if you can route traffic through there and it's HTTP traffic, it's just like working with a regular web application. Canopy for doing the same thing, but with binary data. Some of you will have heard of Echo Mirage. Canopy is like the better version of Echo Mirage, because Echo Mirage is old and doesn't work anymore. Just Decompile is a tool by Telerik. That's for .NET .NET decompiling. I should point out that if any of you have never decompiled a .NET application before, the decompilers are now so good that when you decompile an application, a lot of the times you can actually export a project file, load that back up in Visual Studio, and the decompiled code will recompile and work. It's that good. JD GUI for doing Java. IDR is interactive. This is Delphi something. So if you come against a Delphi app, that's quite useful because it dumps like loads of the class structure and stuff out. IDA and Binary Ninja for doing disassembly. Debugger. I don't know why I wrote that there. A debugger of some sort, I imagine. I like x64 DBG. Ollie is also pretty good. There are a whole bunch of them. Also, Visual Studio is actually quite good for it. API Monitor, that's a tool by Rohitab that allows you to see all of the API calls that are being done by a process. That's super useful. CFF Explorer, which is basically just a PE image editor, and PEID, which is good because if you get something that's packed, which sometimes does happen, it'll tell you what packer was used and things like that. It also will tell you which version of the Microsoft Visual C++ runtime it was compiled against, if it was, which is quite nice as well. So if you've got stuff that's talking over the network, you want to be able to proxy the network traffic. With a web application, that's generally really easy because your browser allows you to just go, hey, let's just put that through this proxy. Not always so easy with a binary application because sometimes it doesn't want to play ball. Sometimes in the configuration files for the application or just in the application's configuration, it will allow you to specify a proxy. If that ever happens, hooray, because it saves you a lot of messing around. You can also set up your hosts file. So if you know it's talking to a particular domain, you can set up your host file to change the IP of that domain to localhost, and then you run a transparent listener on like Burp or something and just pass it through and out. You can use the system proxy. The number of times that an application actually respects the system proxy, I would say somewhere around none. And then you've got the difference between SOCs and transparent proxies. If the application does actually support a proxy being set, then you can set up a SOCs proxy usually. If it doesn't, then you have to use a transparent proxy, which basically the idea is you set up a proxy that listens on a particular port, you mess with your hosts file or even edit the application itself to change the domain that it's trying to talk to go back into localhost. The application then connects to that proxy on port, and then it transparently forwards that out to the original endpoint. Unfortunately, that can be quite a rigid and time-consuming thing to set up, and it's kind of annoying. So, languages that I tend to see, C# is definitely at the top. Java following shortly behind. VB.NET following shortly behind that. Rapid application development languages that just everybody's using these days. Anything from banks to trading companies to governments to ERP software. Everything just is generally now these days written in C#, Java, or VB.NET. It's really common. C++ follows shortly behind that. Unfortunately, Delphi and VB6 and VB5 are still being, either they're still being written or they're just still around, which is kind of annoying. Go away, Clippy. I don't know why I put that in there. So C# and Java, easily decompiled. VB.NET, easily decompiled. Same thing with C# and VB.NET. In case any of you are unaware, both of those are front-end languages that compile to an intermediate language called CIL, or MSIL, which is the old term. And then they run on the .NET framework and .NET runtime. They are actually almost interchangeable. You can make them work with each other very easily, and you can decompile one and then turn it into C# and then recompile it as C#. It's kind of weird. Java, again, easily decompiled because that's a JIT language with an intermediate language as well. C++, yeah, it's assembly, and generally you don't get much out of it more than if they left in the original names, like the mangled names of functions and stuff, especially if they're doing exports. You get a bit of metadata there, but almost nothing. It's mostly just assembly, same as C. Delphi and VB5 and VB6, you do get some metadata in there. And there are specific tools to pull that data out. It makes things a little bit easier. So, now that I've sort of given you an overview, business logic failures. User access controls, business processes, regulatory requirements are the sort of the high-level things that fit under this. So, for example, should this user be able to access this? Or let's say, for example, let's say you've got an application that handles financial transactions for a bank. And the policy is that this is being used by call center workers. And the call center worker can log into an account and be like, right, I'm going to make this transfer. If the transfer is above £10,000, there is a specific set of logic in there that for anti-fraud logic and anti-money laundering logic, where that transaction has to be elevated to a supervisor who can then approve it, and then it goes away. That's a piece of business logic. If you can get around that, such that a call center worker can make a transaction that's more than £10,000 without having to go through this supervisory approval process, that's a violation of the business process, and that is classed as a security issue. That's actually one of the biggest things that we come up against in any application, is it essentially doesn't enforce the process that it was intended to enforce. And then also the regulatory requirements. For example, in that example that I gave, the anti-money laundering thing is a regulatory requirement. It's also probably the law, I think. Basically things not adhering to those regulatory requirements, again, can come up as a security issue. So, in order to find these business logic flaws, you just use the application. You modify traffic to do silly things. You might want to modify the application to do things it shouldn't. If things are being enforced on the client side, but not on the server side, you might be able to do some silly things there. That comes on to a different vulnerability type we'll talk about in a little bit. But sending direct requests and things like that. Essentially, you're looking for processes that should normally be followed and whether you can skip over certain parts of it. So there might be, for example, a specific endpoint that's used to make a transfer, but the client side flags up that it needs to be escalated and says, oh, escalate this transaction, sends off this request to the server to escalate the transaction. What happens if you just submit the transfer? Well, sometimes you can bypass things like that. How do you fix it? It's specific to the individual bugs. The problem is that you essentially have to understand the application in order to do this, in order to give advice about how to fix things. So in general, what you would do is you would sit and look at the user manual, you would speak to your client contact and work out how things are meant to fit together. And if they're not fitting together like that, you've got to think about how they can fix this. So that might be a technical recommendation of you need to ensure that this workflow, this secondary part of the workflow can't be done before the first part is done. Things like that. The secure development lifecycle does help to an extent with this because it makes developers think about security at each step and how things are being enforced. And the last one is a question because, unfortunately, despite giving this advice quite a lot, it never seems to happen, but build security into designs from the ground up. When you're architecting an application and you're in the initial design phase, build security in right there. But unfortunately, that's not very useful advice to give to a client when they've already written the application. So, bug number 2, architectural failures. So these are fun. These are things like client-side enforcement of security. So stuff that the client makes you do that the server doesn't make you do. So if you modify the client or just don't use the client, then you can just make it do other things. Applications where the communications model is it talks to a SQL server. There is no server backend, it's just a SQL server. And if you are a user, you have all of the access that that SQL user has. And that usually means that you cannot possibly enforce any kind of business logic unless you're using like prepared statements in a really clever way and very heavily locking things down. Generally, any application you see that directly talks out to like SQL is a bad idea because the way of enforcing the security model just ends up being almost impossible because you can just modify anything that you have access to. And insufficient authorization capabilities. So situations where, for example, you've got a single web service and a lot of things consuming this web service, and they all essentially operate under the same level of authorization, the same privileges because the web service doesn't know who's talking to it at any moment in time. I once did a test for a financial organization where they had a website on the internet which just did like a basic, I think it was like a loan application check or something, something very simple. It was like you could put in an application ID and it would tell you the status of the application. That was talking to a web service. That web service was also talking to their call center software, which was allowing people to actually proceed through processes. It was also talking back to the accreditors. But the web service had no idea which of these endpoints was who. So everybody had every possible privilege. So it meant that if you pop the web application, you can then do refunds of 10 grand to your account with no problem because it didn't know who you were. It thought everybody had the same sort of authorization. So the lack of implementation of that kind of authorization granularity and understanding identity and things like that, if that's missing, it would be quite difficult. So you can't trust the client. Even if you're in a sort of business environment with locked down laptops, eventually, given enough time with physical access to the machine, somebody will work out how to pop it. You will have an update to the operating system that breaks a piece of group policy and somebody will get around something. It's always possible. You can mess with the client. You could just not use the client. So here's a fun case study. Does anybody remember this game? Hands up if you remember MapleStory. I found the nerds. Great. MapleStory was this game that it was like an early side-scroller MMO thing. It was a lot of fun. But it had this problem, which was that literally everything was being done on the client side. Your health, where monsters were, things like that. So you could get these hacks. God mode. all of these fun things. My favorite one is this thing called VAC. What VAC does is it transports all the monsters on the map to your position. VAC is fantastic. It also does it with all of the treasure and things like that. Because all of the, and this was a multiplayer game, and because of the way that the application was architectured from the ground up, the way it worked, it was impossible for the server to verify that anybody's state was the one true state of the application. So you could just have things happen that weren't happening on the server, but you were still getting the benefits of them. So you could move all of the monsters to your position and then kill them because you've now got God mode and everything you do does like a critical attack hit. Then all of the treasure spawns directly on top of you after you've killed them, and you get all of the level. You level up. You get all the XP. You get all the cash. I don't even remember. It's so long ago that I played this game. But yeah, like there's still forums where people are building stuff for this. It was just a poorly designed game, and that kind of thing also exists in business applications. The idea that things are the security model relies upon the client being left alone. And generally, you can't rely on the client being left alone. So finding them, look at the architecture. I mean, how do you find an architectural vulnerability? Look at the architecture. Bit of a tautology. But if you find things like SQL queries in network traffic, or if it's connecting to a SQL port, also keep in mind that it might not be SQL, it might be Redis, it might be MongoDB, it might be something cloud related. Paco can probably tell you about that. Exposed functions in a WSDL. So if you're talking to a web service endpoint, it might have a WSDL file, WSDL file, which defines the endpoint. They are fantastically useless pieces of information if you actually want to do a web service test, because often they'll be like, do you have any documentation for this? Oh yeah, we got the WSDL file. Great, because all that tells you is the name of the function and the types of the parameters, but no names for the parameters or anything else. It's so useless, and if you need any kind of special IDs or anything, it takes a long time to stop messing with them. However, looking for exposed functions in the WSDL, or looking at how the binary application might talk to it, or even other applications using that same endpoint, how they might do things, adding that all together might give you a good idea of some ways that you could get around business processes and things like that, and find some architectural failures in the way that things are exposed. And of course, reverse engineering and code review. That's the long, boring work, but you can find some cool stuff from it. Exploiting them, modify the client. If it's .NET, if you're using Telerik Just Decompile, there's a plugin called Reflexil, which allows you to arbitrarily modify the code of any method, and change whether fields are like public or private or anything, so you can stop messing with the client in that way. Modify the traffic, so stick canapé or burp or zap or whatever in between it, and as the traffic comes through, modify the traffic in a certain way and set it out. You can always write Python scripts and things like that for that. It's quite nicely. Directly connect to the SQL instance. If you've got an application that directly talks to SQL, you've got the connection string somewhere in there. Take that, directly connect to the SQL database, browse around, see what you can find. And use queries not intended for you. So if you've got an exposed function on a web service, you can start messing with that as well. Fixing them. It's kind of hard. Generally, the problem ends up being that if the application is architecturally broken, you've already architected and written the application. It's really hard to sort of jury-rig security back into it at the end. Re-architecting the application is not something that a client ever wants to hear. And generally, it highlights the need for security at the development phases and the design phases. It's an unfortunate situation for a client to be in if you find that their application is from the ground up just essentially broken from a security perspective. The only way around it is, for example, if you've got this concept, if it's an issue like you're missing the concept of authorization, you can add that in through, for example, having unique client certificates for each service that then talks in, and then you can work out which one is which based on those client services. So you can add that in at that level. But if it's something like it talks to a SQL database as the full application communications design, You can't really fix that very well. The only way to get around it sometimes is to put everything in some kind of like VDI instance or something like that. So things like Citrix XenApp and XenDesktop. Idea being that when you go to connect to an application, instead of the application being installed on your box, it's actually installed on a remote box that you're sort of RDP'd into, sort of. So it gets you away from being able to mess with the application. Sometimes, if you do it right. Unfortunately, they don't always configure that correctly. But it is an option. So, man in the middle, or cat in the middle. I don't know that you can tell that I like cats and swear trek. So, yeah, man in the middling things. You probably already know what that means. Essentially, you've got some network traffic, get in the middle of it, mess with it, see what it does. So missing and insufficient transport security is an incredibly common vulnerability that we run into. You know, something's talking to some service on some port somewhere. It might be HTTP traffic. It might be some random binary protocol that they came up with. It could be anything. And they're just not putting any form of encryption or authentication, integrity checking, and things like that on there. Or if it uses SSL and TLS, the application just decides not to check the certificate. So you can just go in and just put your self-signed certificate in there, and it just accepts it. So it might as well not have TLS from the perspective of a man-in-the-middle attack. And then homebrew crypto, because devs love homebrew crypto. Yeah, like static strings in an application that then get XORed with every packet repeatedly, and it's so trivial to break once you know how it works. Or yeah, they'll use AES and they'll like HMAC every packet, but then the keys for that are static and just in the binary application. So it's like, well, now I know them, you have no security. Yeah, missing authenticity records as well. So a lot of the time in homebrew crypto stuff that people set up for a particular protocol, they'll do something like, they'll use AES, or they'll use RC4, or they'll use something like that. But they won't actually authenticate the traffic, they just encrypt it. Unfortunately, due to things like malleability attacks, what you can actually do is, if you know what some of the plaintext is, you can then actually flip the bits of the plaintext, so it makes it send other things over. You can do things like, say, for example, you know that there's a, I don't know, some field and it's like admin 0 that's been encrypted. Well, if you know where the 0 is, you can just flip the bit to be a 1. The encryption only provides confidentiality. It doesn't provide authenticity or integrity. So if there's no authenticity record, you can just start messing with data. So finding man-in-the-middle problems, yeah, look at the traffic. Like, it's fairly obvious. Reverse engineer the code and then actually man-in-the-middle it. Reverse engineer the code is actually optional, but it's just useful. Man-in-the-middle of the traffic, see what's coming through, mess around with it, see what happens. Again, Burp Suite or Zap for HTTP stuff, Canopy I like for binary stuff. There are other options. You can write your own little Python scripts and things like that. And then just work out what happens when you mess with things. And also just look at what's in there. Sometimes there can be highly sensitive information is being transferred over the network, either not protected or weakly protected. And then somebody who's sniffing that traffic can then see all that stuff or extract it. For TLS certification stuff, I apologize that looks really weird. So finding bad TLS validation in C#, the best thing to look for is just the word server certificate validation callback, which is essentially a global thing for the application using this thing called Service Point Manager, where you set a callback for every time it tries to do a web connection out to somewhere that's HTTPS. It calls this function, and no end of times I will find that it's set to this function where it just says return true, which is basically accept anything. It could be expired, it could be a code signing certificate rather than a web certificate, it could be self-signed, it could be anything, it could be completely invalid, and it just accepts it because it just says, oh yeah, that's fine, return true. Sometimes you'll see people doing clever things like pinning in there, but then what they'll do is they'll pin, but then they'll forget to call the parent callback. So they only do the pinning check. They don't do any other check. So that's always quite funny. The pinning check is always, well, very often not based on like a certificate fingerprint. It's more often than not something like, is the issuer this string, which is utterly trivial to bypass just by self-signing your own cert with the same string. It's just not got the validation chain. But as long as that's broken, then you can just get past it. Java. As usual, Java makes it really long and difficult to read. I don't see the word factory on there, though, so it can't be real Java code. So while this looks quite complicated, oh, it does have the word factory. Good. Oh, yes, good. Get socket factory. So there we go, and that's how we know it's Java. So the way that Java does it is you set up a this trust manager thing where it's sort of subclassing the default trust manager and allows you to just return certain things. So the idea, the way that Java works is it doesn't return true or false. It does nothing or it throws an exception. If it does nothing, that's an accepted certificate. If it throws an exception, there was something wrong with the certificate. So the way that Java works is you do all this rubbish down at the bottom and you're essentially assigning this trust all certs trust manager to the SSL context, and then when you do a HTTPS request, it then it basically calls into these methods inside this trust manager. So it says get accepted issuers. So are there any accepted issuers that you need to be like restricted to? Check client trusted, check server trusted. So if it's a client certificate or a server certificate, those get called. As they both do nothing, they accept everything. So it's the same vulnerability again. It's just harder to read. And if you're looking for this kind of vulnerability, you want to look for like one of these obvious strings like X509 trust manager, or what's the other one? There's a thing somewhere around here that I can see. Where is it? Set default host name verifier is the other one that you should look for. And more often than not, anything that anybody does with any of these is probably vulnerable. They have some use, for example, saying, I will only accept a certificate if it has, the server certificate, if it has this exact fingerprint. So you can pin it down to a very specific certificate, which is quite useful and really good security if they actually do it. But unfortunately, most people do it the other way and just say accept everything. Fixing them, use TLS. Enforce certificate checking, which is not hard because you do nothing. By not subclassing or setting a callback, it just works. It uses the system default validation routines, and it just works. So the solution is to do less than they're already doing if it's a vulnerable system. And then, of course, certificate pinning if you want to add that in, if you trust yourself to do it sensibly. This is probably one of my favorite GIFs on the internet. It's so good. Yeah. It's even better when it's got the shooting stars music over the top of it. Unfortunately, I couldn't get that in. So, handling untrusted data. This is just a lot like web application testing. It's just a binary application instead. So you're sticking weird SQL strings, LDAP strings in there and seeing what happens. Malforming packets, if you're having them come in over the network, just like mess with them randomly and see what happens. If you can reverse engineer the packet format and it's got some like, a number of records and it's like 4, change it to like 6 million and see what happens. You get memory corruption bugs and then you get all of the remote code execution ownage. DOS via zip bombs. Yes, this is still a thing. There are still applications that accept like zip files over a network and then unzip them, which can have amusing consequences. And then attacks on deserialization, which I'll talk about in a minute, but they are a great way to get remote code execution. So finding and exploiting SQL injection, read a web app book. Like if you've exploited SQL injection on a web app, you can do it on a binary app. It's the same. Look at the code, see if they're doing silly things with SQL, particularly on server-side applications. Just use the usual exploit techniques. You can more often than not use what's the name of the tool? SQL map. As long as it's not like a weird binary protocol, which makes it kind of harder. But yeah, a lot of the time, just finding things is put the SQL characters, the ones that everybody knows, the SQL injection characters, the quotes, and all of the silly ones, in every field, and see what happens. And if it breaks, you've maybe got a good idea of what's happening there. Parsing bugs. So, fuzz the parser. If you've got some data that's coming in, so for example, it might be JSON, it might be XML. For XML, enjoy hating your life while you're testing it. If it's something weird and binary, yeah, script some attacks. Do something with Python. Use some existing file or packet format fuzzers. There are some really good ones for network packet stuff, and there are some really good ones for file stuff, where you can take you can write like a YAML, I think it's YAML, file format spec, pass it to the fuzzer, and it generates a whole bunch of files based on that spec. And then you can load those files into the application and see what happens. And sometimes you'll get a crash, and that crash might give you like code execution, or it might just give you something, I don't know, maybe interesting. But that's useful for cases where, for example, somebody's loading a file off a USB stick or something. I think actually it might have been the same one, the same application, the same financial application that was doing the weird web service thing. Their application also had a thing where you could take a mortgage application file, which was like if you had somebody from that company go out to meet you and have a meeting with you, what they would do is they would fill out your application details in this application and then export it. But if they didn't have network access, like if this was on a laptop somewhere without Wi-Fi, they could then export that file. Then when they get back to the office, load that file back in, or just email it off when they get access, and somebody else can then go and carry on messing with it. Loading that file in, it turns out that there was a bunch of ways that you could mess with that file and get like memory corruption when it loaded it back in. I think one of them was also a zip format, which again meant you could do silly things like zip DOS, where you would open a 1 kilobyte zip, extract it, and it takes up 1 terabyte on your disk. That's always fun. And then you get things like AFL, which I don't know whether many of you have heard of, but it's like a common fuzzing library thing, but that gets compiled into the code. So if you don't have the source code in the build environment, you can't really get AFL on there. It's very rare that I'm in a situation where I actually get to use AFL, but if you do, use that or something like it. It's quite useful. Again, look at the code. Seems to be what I say every time. But yeah, have a look at the code. See how particular things are being handled, and think about how you might be able to get around particular checks. There's no end of times when it'll be like looking for integer overflows or something, and they'll check for one. The check that they've got is actually broken, and you can get around it and cause all sorts of mayhem in the memory. Not so much in C# or Java because they're managed, so they don't tend to fall into memory corruption bugs. But again, debuggers are useful. Yeah, just spoke about this. So anytime the application takes a .NET or a zip or whatever, you can just create these crazy zip files. They're like a couple of kilobytes, but when you expand them, it essentially expands to just ludicrous amounts of data. And then just, if you can do that on a server, and your goal is to DOS the server, it's a good way to DOS it, because if it's ran out of disk space, then it can't write logs, and then you get an exception in the log handler, and then the whole application falls over. Because nobody expects that the log handler won't be able to write out. So often the error handling is really bad there, because often the error handling is the log writer failed to write. I'm now going to write a log of that error to the log file. Guess what happens? That creates an exception. So it writes the exception to the log file. That creates an exception. So yeah, it just falls over. And yeah, you can sometimes do that over HTTP. Sometimes there's things where you can like you can use like a web service endpoint to upload a file and knock over a server. So deserialization attacks, these are fun. I'm not going to go into them in massive detail. I think I actually gave a talk on them at some point. But essentially, serialization is you take an instance of an object in a language like C# or Java, and also PHP, and you turn it into some piece of data that you can ship somewhere. And then on the other end, they can take that data and turn it back into an object. So let's say you've got a dictionary object that's full of strings, or let's say a list object that's full of strings. You can then take that object, turn it into a big blob of data. This might be binary data, it might be JSON, it might be XML, it might be anything. And then at the other end, it goes whoop, and then turns it back into a running object. This is also possible for like classes. So let's say, for example, you've got a I don't know, customer class. You get an instance of that customer. It turns that into a binary blob of data or some JSON, and then turns it back into this customer object at the other end that you can then do work on as if the same object existed in both places. Unfortunately, it turns out that that's kind of fraught with danger, because if you then pass that over an untrusted channel and then you mess with that data, well, for a start, you might be able to mess with things that had business logic requirements around them. But that's kind of the boring side of things. What you can do instead is you can just change which type it was. So instead of a customer object, you've got then some other weird type that when you deserialize it at the other end, does something nasty. I won't go into it too much, but essentially, yeah, the attacker replaces the genuine content with something sketchy, and the side effect of the object being either created or destroyed on the far end actually can lead to remote code execution. So here's a quick example. This is from C#. So you use this thing called a binary formatter. That's basically a thing that serializes and deserializes objects. So you take some packet from a client. So let's say, for example, it's taking this packet off the network, puts it in this byte packet variable, and then it deserializes the packet into this foo packet type, into this variable foo. So this is this cast here, because this generates an object, and then you want to assign it to the left-hand side there. Now, the vulnerability there is not immediately obvious. However, this is what really gets generated. So you've got this binary formatter, you get this binary packet, so it's a bunch of data. Now, what really happens is that cast is then actually split out. The evil object gets put onto the heap of the application. Then they try to cast this evil object to foo packet. Now, evil object and foo packet are two different things. So it's like, this is apples to oranges. I'm not going to do that. So it throws a type casting exception. So this temporary variable that's on the heap now goes out of scope because the exception causes it to jump out of scope. It leaves the method. The temporary variable is now out of scope, so the garbage collector finalizes it. Now, if there's something in the finalization logic that causes remote code execution, for example, there are some things to do with scripting environments, some classes in the .NET framework to do with scripting environments that when you tear them down, you can have a teardown script, and you can actually pass that inside of the object so that when it comes through and the application goes, that's not what I was expecting, gets rid of the object, and then the object runs its finalization script, and that finalization script gets you RCE. So finding deserialization bugs. And don't think that this has to be done manually. I'll explain why in a minute. Yeah, finding them. You want to look for data from an untrusted zone, for example, the network, but also files, files that the user might be given over email or something like that. It's really common in packet parsing in Java and C# to find these things. You trace the function calls from where data comes in from a packet to some sort of deserialization call, and then verify that you can send untrusted data there. And once you've verified that, you know that you've got a bug. In C#, if they use any of these, there are probably some more as well, to deserialize untrusted user input, you can get RCE. It's actually not that hard. And then in Java, you've got object input stream and XML encoder. They can subclass those to do some decode stuff. But yeah, if they're using those, again, you can get RCE, and there's lots of third-party libraries that you can do that with as well. These two tools are fantastic because you can just generate a payload that gets you a shell or runs a command on a box, and then just send that, and then it just works. It's super simple. So you got one for Java, one for .NET. So yeah, go check those out. And fixing them. Now in .NET, I'm really short on time. Okay, in .NET, binders are essentially a way of taking in, writing a function, like a callback function that checks whether, well, it's actually, you have to write a class, but it checks whether the type that's trying to be loaded can be loaded. So it sort of says, I would like to create an object of this type. And the binder has an opportunity to say, no, you're not going to do that. So you can restrict the types that are coming in. It is a little tricky to implement, but it's actually quite useful. And it's about the only way to fix deserialization bugs, short of writing your own deserializer that only works for your particular types of class, which is a lot of headache and gets rid of a lot of the reason that people use serialization. Java, same thing, but it's just subclassing the object input stream to use the resolve class method. So when it calls back, when you go to deserialize something, it calls this resolve class method, and your resolve class method can say, no, I'm not going to resolve that class because it's not within my whitelisted trust list of things that I'm going to take apart. And the last one. Yeah, I did say I like swear trek. So Windows objects. So there are actually three namespaces in Windows: files, registry, and objects. I imagine a lot of you, as you were growing up, thought files were the only thing that existed and didn't know about the registry, and were like, oh, where is this config thing stored for this game that I'm playing? And then you realize that the registry exists, and you're like, oh, wow, this is this whole other thing. There's also another one called objects. So things like drivers, devices, events, mutexes, semaphores, blah, 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 all get put into this object namespace. Well, named ones do. Non-named ones, you can get a handle to them, but they don't exist in the namespace. There's a tool called WinObj, which is from sysinternals, that lets you browse them. And by default, they're insecure if you create them. So this is what WinObj looks like. And this is what the object namespace looks like. And then you've got all these objects. So you've got events, mutexes, jobs, timers, sections. Sections are like mapped memory map files, or mapped memory, like shared memory, if you're familiar with those terms in Linux. The permissions model is quite funny. So just going back one, you see at the top you've got this like backslash in the folders, and then everything comes down from there. So APIs allow you to pass an ACL, a security context, I think it's called, security attributes. So an API like create mutex, or create, I forget what the ones, create semaphore or things like that. If you pass null, it just gives it no ACL, which means that everybody can access it. If the parent directory doesn't have an ACL that is inheritable, the ACLs are inherited down that tree, and the root ACL is null. There is no ACL, and a null ACL means anybody on the system can access it. So by default, if you create a mutex with a name and you don't give it an ACL, everybody on the system can access it. This is quite useful for privilege escalation, particularly if drivers are doing this kind of thing, because you can then stop messing with, for example, if it's got shared memory from a driver to user mode, you can stop messing around with things like that. Or if the driver itself doesn't have an appropriate ACL on its driver object, you can start calling IO controls into the driver, which might do things in the kernel that you shouldn't have the privilege to do. If anybody remembers the ASUS UEFI update driver bug that was around about a year ago, that allowed you to map all kernel memory, that's how that worked. I actually found it before the guy who reported it found it, but then he managed to get through the disclosure process faster than me, because it took ASUS 2.5 years to get through mine. Finding the weak object permissions. Process Explorer's handles view is great because you can see what objects a particular process has handles to, which is great if you're targeting a particular application. You can use WinObj to then go through and look at them a bit more. You can right-click on any of those objects in WinObj and then click Properties, and you can see all the security controls, if any. Often it's null, which means you can mess with them. You can also use API monitoring to see what's being called and what's being created. When you exploit them, the exploitation is local. There's no network access to this stuff. So local priv-esc at best. But cross-user is quite interesting on multi-tenant systems. I have found stuff and multi-tenant systems do sort of exist sometimes. On the desktop model, it's total nonsense. Any vulnerability that anybody reports that's multi-tenant for like Windows desktop users is just nonsense because nobody's ever logged into it concurrently. But sometimes you can run into cases where it's quite useful. And shared memory is often interesting. So quick case study, application virtualization. Yep, sorry, running late. Application virtualization software might be one that I mentioned earlier. Has a thing where applications that are running in this virtualized desktop, perhaps over multiple desktop instances, share a specific set of memory. So there's basically every process has this maps this piece of shared process because it's loading it's loading like a particular DLL for doing some stuff that allows you to copy paste in and out of the virtualized environment and things like that. But the memory itself is not protected because the DACL is null. But it injects into this thing is injected into every process on the system, including ones that run as system. And the memory contains a DLL to the path to the binary that needs to be injected. So if you just change the path, every process on the system loads this binary, which gets you immediate priv-esc to system. Although if you point it at a non-existent DLL, the error handling case in this was just to continue trying, which means that every single process on the box suddenly goes into a spin loop, which hoses the entire instance and means that the only way to kill all the instances is to reboot the virtualization server, which was, I found that by accident. Weak object permissions, case study 2. Sophos antivirus had this issue where you could, there was a bunch of mutexes that were run by the scanning drivers, but they were not protected. You could acquire all the mutexes, all of the scanning threads would then stop, and you could basically just halt the AV scanning, which meant that you got, eventually what happens is it sees it as the OS sees it as a kernel thread hanging, and then BSODs the box. But in the time between that, which is I think 15 seconds or something, you can essentially do anything you like, and the AV can't stop you, which is quite fun. So fixing them, pass an ACL to any of the APIs when you're creating mutexes, drivers, or anything like that. And you can copy them directly from your process if you want the same ACL as what your process is running at, or you can generate them manually. There are APIs to do that. So in conclusion, binary applications are challenging, but also fun. There's lots of cool things you can find. My top 5 here is definitely subjective. This is based on my experience of testing binary applications. What somebody else does in a different sort of industry vertical, what they're playing with is probably different. If you can test a web application, you can probably test a binary application. It's like the approach is largely the same. It's just different tooling and different technologies that you're playing with. So it's, and you don't need to be elite exploit dev. You don't need to be able to, build ROP chains and bypass ASLR. That stuff almost never happens. I never look at meta. I think I've used Metasploit twice in my entire career. So yeah, you don't need to be an elite exploit dev. You can learn this stuff quite quickly. And there we go. Thank you. Any questions?